Hi students, in last class we discussed about the periods in the modern periodic table. In this class we will discuss about classification of elements into blocks and classification of elements based on properties. Classification of elements into blocks. Before going to discuss about classification of elements into blocks, we will discuss what is differentiating electron. Differentiating electron. The last entering electron of an atom is called differentiating electron. Last entering electron of an atom is called differentiating electron. For example, if you take sodium atomic number is 11. 11th electron is the last entering electron. If you take zinc atomic number is 30. 30th electron is the last entering electron. Based on differentiating electron, the elements are classified as S block elements, P block elements, D block elements and A block elements. Based on differentiating electron, elements are classified into 4 types: S block elements, P block elements, D block elements and A block elements. First one, S block elements. Elements in which differentiating electron enter into S orbital are known as S block elements. Elements in which differentiating electron enter into S orbital, last electron enter into S orbital, those elements are called S block elements. Already you know valency cell electronic configuration for the groups. First A group element general configuration NS1. Second A group element general configuration NS2. So first A group elements and second A group elements commonly called as S block elements. First A group elements and second A group elements commonly called as S block elements, because in first A group and second A group, last entering electron or differentiating electron enter into S orbital, so they are called S block elements. Their general or valency cell electronic configuration is NS122. First A group elements general electronic configuration is NS1. Second A group elements general electronic configuration is NS2. So S block elements general valency cell electronic configuration is NS122. Except hydrogen, all S block elements are metals. They are highly reactive. S block elements are metals and they having high reactive nature. They will react with the other elements and they will form compounds. Now we will discuss about P block elements. Elements in which differentiating electron enter into P orbital are known as P block elements. Elements in which last entering electron or differentiating electron enter into P orbital are known as P block elements. 13th group to 18th group. 13th group is nothing but 3rd A and 18th group is nothing but 8th A or 0 group. 13th group to 18th group elements are called P block elements. Already you know 13th group or 3rd A group general valency electronic configuration is NS2NP1. For 14th group NS2NP2. For 15th group NS2NP3. For 16th group NS2NP4. For 17th group NS2NP5. For 0 group NS2NP6. In all these groups, differentiating electron enter into P orbital. That's why these are called P block elements. Their general or valency cell electronic configuration is NH2NP126. NH2 NP1 to 6. is the general or valency cell electronic configuration for p block elements. This includes metals, non-metals and metalloids. In p block we can observe some metals, some non-metals and metal. For example, aluminum is a metal, fluorine is a non-metal and germanium is a metalloid. Now we will discuss d block elements. Elements in which differentiating electron enter into d orbital are known as d block elements. Elements in which differentiating electron enter into d orbital are known as d block elements. Third group to 12th group elements are called d block elements. Third group is nothing but third B and 12th group is nothing but second B. Third group to 12th group elements are called d block elements. Their general or valency cell electronic configuration is n-1d 1 to 10 ns 1 to 2. If you observe scandium to zinc, scandium valency cell electronic configuration is 3d1, 3d1, 3d2, like that. Zinc electronic configuration is 3d10. So last electron enter into d orbital. That's why those elements are called d block elements. General electronic configuration for d block elements is n-1d 1 to 10 ns 1 to 2. Here n-1 cell is called penultimate cell. Last but one cell is called penultimate cell. These are hard metals with high melting and boiling points. D block elements are hard metals and they have high melting point and high boiling point. Now we will discuss about a block elements. Elements in which differentiating electron enter into f orbital are known as a block elements. Elements in which differentiating electron enter into f orbital are known as a block elements. Their general or valency cell electronic configuration is n-2 f1 to 14 n-1 d 0 to 1 ns2. General or valency cell electronic configuration is very important for a block elements. General or valency cell electronic configuration is n-2 f1 to 14 n-1 d 0 to 1 and ns2. Already we discussed n-1 cell is the penultimate cell and n-2 cell is the anti-penultimate cell. Last but one cell is the penultimate cell and last but two cell is the anti-penultimate cell. Last cell is the valency cell. There are 14 elements from third B group, 6th period, and 14 elements from third B group, 7th period. This is very important. A block elements belongs to third B group. 14 elements are nothing but lanthanides. They belongs to third B, 6th period. And another 14 elements nothing but actinoids. They belongs to third B, 7th period. Lanthanides and actinides commonly called as a block elements because in that elements differentiating electron enter into f orbital. Lanthanides are soft metals and actinides are radioactive metals. Lanthanides are the soft metals. Actinides are the radioactive metals. They will emit the radiation. For example, uranium emit the radiation, plutonium emit the radiation, neptunium emit the radiation. Elements which have atomic number more than 83 are the radioactive metals. They will emit the radiation. They will use it in the nuclear power reactors. Lanthanides are also known as rare earth metals. Lanthanides also known as rare earth metals. They are placed at the bottom of the periodic table. A block elements are placed at the bottom of the periodic table. Here we can see modern periodic table. In that, first group, second group elements are the S block elements. 13th group to 18th group elements are the P block elements. Third group to 12th group are the D block elements. And at the bottom we can see lanthanoids and actinoids. Those are commonly called as F block elements. F block elements belongs to third group 6th period and third group 7th period. Here we can see in third group lutetium and lawrencium we can see. The actual place of the F block elements is that. Complete the following table using periodic table. This is the textual question. Here directly we are answering the question. First period contain two elements from hydrogen to helium. Those are belongs to S block elements. Here we have to remember one thing. Even though helium is placed in 0 group, helium electronic configuration is 1s2. Differentiating electron enter into s orbital. That's why helium also belongs to S block element. Second period, total number of elements 8. From lithium to neon. Here 2 are the S block elements and 6 are the P block elements. Third period, total number of elements 8. Sodium to argon. In that 2 are the S block elements and 6 are the P block elements. Fourth period contain 18 elements from potassium to krypton. In that 18 elements, 2 are the S block elements, 6 are the P block elements and 10 are the D block elements. Fifth period again contain 18 elements from rubidium to xenon. In that 18 elements, again same thing. 2 are the S block elements, 6 are the P block elements and 10 are the D block elements. Sixth period contain 32 elements from cesium to xenon. In that 32 elements, 2 are the S block elements, 6 are the P block elements, 10 are the D block elements and 14 are the F block elements. Seventh period also same thing. It contains 32 elements from francium to oganesine. In that 2 are the S block elements, 6 are the P block elements and 10 are the D block elements, 14 are the F block elements. This is the classification of elements based on differentiating electron. Now we will discuss classification of elements based on properties. Elements are classified into 4 groups on the basis of their properties and electronic configuration. Again, elements are classified into 4 groups basis of their properties and electronic configuration. They are, first one is noble gas elements. Second one is representative elements. Third one is transition elements. Fourth one is inner transition elements. Noble gas elements, representative elements, transition elements, inner transition elements. Now we will discuss one by one. First one is noble gas elements. The elements belongs to 0 group or 18th group and which are placed extremely right side of the periodic table are called noble gas elements. Noble gas elements are nothing but 0 group elements or 18th group elements which are placed extremely right side of the periodic table are the noble gas elements. They are helium, neon, argon, krypton, xenon, xenon, and oganesine. These are the noble gas elements or zero group elements. Their general electronic configuration is ns2np6. Except helium. Helium configuration is 1s2. Except helium, all the noble gas elements general electronic configuration is ns2np6. Due to this stable octet configuration, in noble gas elements, valency cell is completely filled. They contain 8 electrons in the valency cell. They will follow octet rule. That's why they are stable. They are chemically inert. So they are called inert gases. Their valency cell is completely filled. They are stable. They do not participate in the reaction. They are chemically inert. So they are called inert gases. They are also called as rare gases or noble gases. They occur in the atmosphere in very rare quantity. That's why they are called rare gases or noble gases. All are monoatomic gases. Noble gases are monoatomic gases. Except radon and oganesine, all are present in air. They are present in atmosphere or air. Now we will discuss about representative elements. Except to zero group, remaining S and P block elements are called representative elements. Except zero group, remaining S block and P block elements are called representative elements. Or first A group to 7th A group elements are called representative elements. The general electronic configuration of representative elements is ns1 to ns2 np5. Their general electronic configuration is ns1 to ns2 np5. In these elements, last cell is incomplete. In these elements, last cell is incomplete. So these elements gets nearest inert gas configuration by losing or gaining or sharing of electrons. In these elements, last cell is incomplete, incompletely filled. So they get nearest noble gas configuration or inert gas configuration by losing the electrons or by gaining the electrons or by sharing the electrons. That is nothing but forming chemical bond. Thus, they are chemically active. So, they are very chemically active. They will participate in the reaction. Without these elements, compound cannot be formed. Without representative elements, compound cannot be formed. They represent entire chemistry. Representative elements represent entire chemistry. So, they are called representative elements. Because they represent entire chemistry, they are called representative elements. Now we will discuss about transition elements. Except second B group, remaining D block elements are called transition elements. Except second B. In second B, zinc, cadmium, mercury are there. In that elements, D orbital is completely filled. So except second B, remaining D block elements are called transition elements. Their general electronic configuration is N-1D 129 NS122. N-1D 129 and NS122 is the general electronic configuration for transition elements. In these elements, last two cells, nth cell and N-1 are incompletely filled. In transition elements, last two cells are incompletely filled up. Due to small size of atoms, higher nuclear charge and availability of empty d orbitals, these elements shows characteristics properties. D block elements have small size and higher nuclear charge. They have higher nuclear charge, availability of empty d orbitals. These elements show characteristic properties. They are hard and heavy metals. D block elements are hard and heavy metals. They are good conductors of heat and electricity. They have high melting and boiling points. They will show variable oxidation states. They will show variable oxidation states. They will exhibit colors. They will form alloys. And they will form complex compounds. And they will act as a catalyst. These are the characteristic properties of the D block elements. They act like a bridge between S and P block elements, so they are called transition elements. D block elements act like a bridge between S and P block elements, so they are called transition elements. Now we will discuss inner transition elements. All the A block elements are called inner transition elements because they are present in between two transition elements. The actual place of the A block elements is in between two transition elements. That's why they are called inner transition elements. In these elements of atoms, last three cells, nth cell, n-1, n-2 are incompletely filled up. Their general or valency cell electronic configuration is already we know n-2f 1 to 14, n-1d 0 to 1, ns2. This is about inner transition elements. Students, all of you write notes and prepare well. We will continue in next class.